Hi students, welcome to Evershine Coaching Center. Myself Faisal sir here. Dear students, today we are going to study the chapter Acid, Bases and Salts. Dear students, I hope you all are fine, doing well, preparing well for your exam. As well, you have studied this chapter very well, but still we are going to discuss few very important points in this chapter, and I am going to summarize the entire unit. So this chapter I am going to make two sessions. In first session I am going to complete now the important topics of this chapter and a small revision, and second session I am going to complete your textual question answers, expected question answers, application level question answers, previous year question answers, etc. So please don't stop watching this video. I want you all want to study and you want to listen, and you have to make a note by taking one rough notebook. Is this clear? Let's begin the chapter. First, we are going to classify the chemical substances into three categories: acid, bases and salts. Now let me discuss few important properties of acids. Now we can see here the term acid. First, let me discuss their physical properties. The physical properties of acids are: they are sour in taste, and of course they are all soluble in water. Easily they will dissolve in water. Any acid you take, maximum acids they will dissolve in water. All dilute acids conduct electricity. Children, here we have a word called as dilute. Now what do you mean by dilute and what do you mean by concentrated? I hope you have seen the word called as dilute HCl and concentrated HCl, right? Now what is this term called as dilute and what is the meaning of concentrated? Are you getting? So dilute acids and concentrated acids. See children, I'll give one small example. देखो बेटा, dilute और concentrated में difference क्या है? चंद acids को हम dilute acids बताते हैं और चंद acids को हम concentrated acids भी बताते हैं, right? Yes or no? Now let me see what is the meaning of dilute and what is the meaning of concentrated. See children, you take a small quantity of milk, example, okay? Or else you can take your Bournvita or Horlicks, anything, okay? Please listen this concept very carefully. If you are adding more amount of water, then it is called as dilute. If in acid is less, we have less acid but more water, then we get the word called as dilute. Are you getting children? Less acid but more quantity of water, that is called as dilute. How much you go on adding water, that particular substance will start diluting more. Similarly, concentrated. How can you make any acid as concentrated? You take acid and you mix with water. But how much quantity of acid and how much quantity of water? Very simple. If we are adding less water, more acid, then we call it as concentrated. Got it? Less water, more acid is concentrated, but more water and less acid. Water is more, dilute. Water is less, concentrated. Simple. Are you getting children? This is the difference between dilute and concentrated. Okay. Now, all dilute acids conduct electricity. Word is dilute. Do not forget. These dilute acids conduct electricity. All dilute acids will conduct electricity, not concentrated acids. You should know the difference between dilute and concentrated. And it changes blue litmus to red. See children, if you find a color called as red, red means danger. Danger means acid. Simple. If it is already red, then it is acid. If any color is changing to red, then that particular substance is acidic in medium. It means that is acid. If you find red color, then it is acid. So based on strength of hydrogen ions or hydronium ions, okay, see children, based on the strength of H plus ions, that is strong acids and weak acids, we classify based on the strength of acids, we classify them on the basis of strong and weak. Strong acids like HNO3, H2SO4, HCl. Are you getting children? Even you can take HCl also, like HCl. Okay. Hydrochloric acid, sulfuric acid, nitric acid. So these all are considered as strong acids. Similarly, weak acids like we can see HCOOH, formic acid, acetic acid, CH3COOH, etc. So these all are considered as weak acids. But comparing both strong and weak, which is the very highly strong acid, that is hydrochloric acid. Which is the weakest acid? A weak acid, that is acetic acid. Acetic acid is considered as weak acid and hydrochloric acid is an example as very strong acid. Now we are discussing only regarding acids. Now these are the physical properties. Physical means which we can see and tell, which we can see and express. That is called as physical properties. Chemical means which we cannot see and tell, but we have to do some experiment. कुछ experiment करना है, तभी हमारे को मालूम पता चलेगा कि वो strong है या weak है. समझ में आ रहा है ना? और similarly और उनके properties. After doing the experiment, we are getting to know that is called as chemical properties. Just by seeing and expressing, what is that? That is called as physical properties. Chemical properties, reaction with metals. Anyhow, we are going to discuss. Even you have got in your textbook. You take so many acids they have given. You react with metal. So what is the compound is obtained? Which gas is obtained? You have to learn about those things. And children's, very important. I can tell you, you can expect definitely one question. Definitely one question you can expect. Based on the topic, this. It's there in your textbook. You should not forget this. Reaction of metal with carbonates and reaction of metal with hydrogen carbonates. Reaction with metal carbonates and reaction with metal hydrogen carbonates. So these are the important two chemical reactions which is present in your textbook. You should not miss this, because this is very important. Reaction with metal carbonates and reaction with non-hydrogen carbonates. Okay, what happens if a metal, okay, or else if an acid, if acid reacts with metal carbonates, what happens? Same thing, if acid reacts with hydrogen carbonates, that is metal hydrogen carbonates, what happens? Okay, and reaction with metallic oxides. These are the chemical properties. So in your textbook, you have got three different topics based on your chemical reactions. Which are the three topics? One is reaction with metals. Another one is, this both comes under same category, reaction with metal carbonates and reaction with hydrogen carbonates. And third is reaction with metallic oxides. Next, types of acids. We classify acids into two categories generally, that is organic acids and mineral acids. Okay, if the acids are produced by plants and animals, okay, from plants and animals, if I are getting an acid, that acid is called as organic acid. Similarly, mineral acids, which we are getting from the earth crust, the acid which is prepared from the minerals present in the earth crust, okay, that is called as mineral acids. So HCOOH, formic acid, acetic acid are the organic acids which is obtained from plants and animals, and mineral acids are nothing but which is obtained from the earth crust, that is called as mineral acid. Example, hydrochloric acid, sulfuric acid, etc. So I hope you have understood the difference between your physical properties and chemical properties, and how we can classify the acid based on the strength. Okay, strong acids and weak acids, and two different types of acids, organic acids and mineral acids. Now similarly, let me discuss bases. So what are the physical properties of bases? The taste is bitter. The taste is bitter. But what about acid? Sour in taste. Khatta. We say khatta in Hindi. Okay. Bitter means kadwa. Okay. I hope you have already tasted that, right? So the taste is bitter. Okay. And similarly, they feel slippery to skin. They feel slippery to skin. Some bases are soluble in water and some bases are insoluble in water. So remember, all acids are soluble in water. Acids are soluble in water. All acids are soluble in water. But in case of bases, some bases are soluble in water and some bases are insoluble in water. They are not soluble in water. So some bases are soluble in water. Very important question. Very important question. The bases which are soluble in water, we call them as alkalis. We call them as alkalis. Okay. And some bases are not dissolved in water. Even that is also base, but they are not dissolving in water. They are not combining or mixing with water. Okay. Example, the alkalis. Example, sodium hydroxide, potassium hydroxide. Sodium hydroxide, NaOH, and potassium hydroxide, KOH. Okay. So these are the different examples of bases. So as I said you, if we see the color called as red, agar se tumna red dikhai de raha, if you can see red color, then it is acid. If you see it is blue, then it is called as base. Simple. Red and blue. Difference. If red is converting it to blue, I have given one element called as X. Let it be in some other state. If you are seeing that X in the shape of red, then it is acid. If you see it is blue, then it is considered as base. If it is changing to blue or it is present in blue, even after dissolving or combining with some other chemicals also, it remains the same state, that is blue itself, then it is base only. If it is changing to blue also, it is base. Okay. So this is the difference between acids and bases. Okay. They are sour in taste, but they are bitter in taste. And all the acids are soluble in water, but they are insoluble in water. And all dilute acids, I said you dilute acid, not concentrated acid. Dilute acid, from dilute acid we can conduct the electricity. Okay. And regarding the bases, some bases are soluble in water and some bases are insoluble in water. The bases which are soluble in water, they are called as alkalis. Example, sodium hydroxide and potassium hydroxide. And what is the what is the change in the litmus we can find over there? They change into blue color. Red is going to change into blue color. Same way chemical properties. In that, how many chemical properties we had? Totally 4, but generally we consider it as 3, right? Metal carbonates, hydrogen carbonates, metal hydrogen carbonates, that is one reaction. Metallic oxide, that is one reaction. And reaction with metal, that is third reaction. Totally we have 3 chemical reactions over there. But in this case, reaction with metals and reaction with non-metallic oxides. So these are the 2 different chemical reactions we are going to discuss based on chemical properties of bases. So which is the strong base? Sodium hydroxide. Sodium hydroxide is a strong base. Should not forget it. Okay. Now based on the strength of hydroxide ions, OH ions. Okay. Hydroxide ions, strong bases and weak bases. Which is a strong base? Sodium hydroxide and potassium hydroxide are strong bases. Weak bases, magnesium hydroxide and ammonium hydroxide, NH4OH, these are the weak bases. Okay. Now we have the reaction called as neutralization reaction. Very important reaction. Neutralization reaction. Neutral means what? It's everything changing into normal state. That is called as neutral. Means if you combine acid with base, it gives salt and water. That is called as neutralization reaction. Combination of acid and base. What happens? If acid and base, if we are going to combine, we get salt. And with some amount of water. So this type of reaction is called as when acid and bases are react with each other to form or to obtain salt and water. Such a reaction is known as neutralization reaction. Okay. Next, indicators. What do you mean by indicators? These are the substances which we are using to detect whether it is acid or base. हमें पता चलना है कि ये एसिड है या बेस है. उसमें कुछ ना कुछ चेंजेस होगा. It changes. Maybe it changes its color, it changes its smell. Okay. Some changes is going to happen from which we can easily identify whether the given solution or given substance is acid or bases. That is called as indicators. Indicators will indicate. They will tell us. वो हमें बताएंगे कि ये जो substance दिया गया है, the substance which we have given, whether it is acid or base. That substance is known as indicator. So we have generally classified indicators into 4 categories. We have 4 categories actually. Okay. One is natural indicator, olfactory indicator, synthetic indicator. Okay. So actually these are the different indicators. 3 indicators I am showing, and one more indicator is there, that is universal indicator. Okay. But here I have shown 3 indicators. Just to study these 3 things. Not present. I'll tell you about universal later. Okay. Anyways, Natural indicator, olfactory indicator, synthetic indicator. Natural indicator, we example is litmus. Olfactory is onion. By smell we can easily identify. And synthetic is nothing but artificial indicator. Okay, example is phenolphthalein. So these are the three different indicators, and remember the examples of this. Very important. Now pH scale. Okay. So what do you mean by pH scale? This is a scale which we are going to use to measure the amount of hydrogen ion concentration in a solution. How much hydrogen ion concentration is present? How much H plus ion concentration is present? To detect that, we are using a scale that is called as pH scale. What is pH scale? It is a device which is used to measure. It is an instrument. It is a device which is used to measure the amount of hydrogen ion concentration. How much amount of hydrogen ion concentration is present in a solution? To detect that, we are using pH scale. In pH scale, generally we have three things. One is 0, 7 and 14. We classify. The one who is coming below 7, that is pH which is less than 7, that is called as acidic in nature. How much it goes? Less, 7, 6, 5, 4, 3, 2, 1, 0. How much it is reducing, that much it becomes strong. That much it becomes strong. So 6 is weak, 5 is little strong, 4 is little bit strong, 3, 2, 1. 1 is highly strong. Okay. Similarly, 8, 9, 10, 11, 12, 13 and 14. Okay. The one who is going towards 14, that is called as basic in nature. The one who is exact 7, that is called as neutral in nature. Okay. Less than 7 is acidic solution, more than 7 is basic solution, and exactly 7 is neutral solution. Okay. Now pH value of salt. So neutral salt is nothing but the pH value of neutral salt is almost equal to 7. Almost equal to 7. Acidic, pH value of acidic salt is less than 7. Basic salt is more than 7. Now we are going to discuss some important chemical compounds such as common salt, that is called as sodium chloride. Children, you can expect, I am saying you can expect one preparation also. So we have different salts here. We are going to discuss in detail, and please you can copy down these notes because this comes under long answer questions. Long answer questions. Okay. Let me discuss some information regarding common salt, that is called as sodium chloride, NaCl. Sodium chloride. So sodium chloride NaCl is also known as common salt. That is nothing but table salt. It is formed after the reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide and hydrochloric acid, NaCl and sodium hydroxide, NaOH. NaOH. One acid and one base. When we are combined, what is obtained? One acid and base. If we are going to combine, what is obtained? Salt and water. What is this reaction is known as? Neutralization reaction. Same thing we are discussing here. Okay. One sodium hydroxide, one base and acid, or acid and base. When we combine both together, we get a neutral salt. Okay. So the pH value of sodium chloride is about 7. It is about 7. Sodium chloride is used to enhance the taste of food. Remember how we get neutral salt? How we get this neutral salt? Okay. So by this combination reaction, HCl, hydrochloric acid and sodium hydroxide. When we combine acid and base, that is hydrochloric acid and sodium hydroxide, we get NaCl. Remember how we obtain NaCl, how sodium chloride is prepared or manufactured. Okay. By the combining हाइड्रोक्लोरिक एसिड एंड सोडियम हाइड्रोक्साइड टुगेदर, जब हम हाइड्रोक्लोरिक एसिड और सोडियम हाइड्रोक्साइड दोनों को कंबाइन करेंगे तो हमारे को क्या मिलेगा? व्हाट वी गेट? सोडियम क्लोराइड. HCl plus NaOH gives salt, that is neutral salt. NaCl is a neutral salt. It is neither acidic nor basic. Okay. So where we are using this is used to enhance the taste of food. In your diary, in our home, everywhere we can see table salt or common salt. That is what to increase the taste of food. We are going to use sodium chloride. Sodium chloride is used in many manufacturing chemicals. Okay, even in manufacturing many chemicals also we are going to use sodium chloride. Some important chemical from sodium chloride. By using sodium chloride is the head of the family of salts. Okay. Now we have classified some other salts which is obtained from sodium chloride, such as sodium hydroxide, NaOH. Okay, important chemical from sodium chloride, that is sodium hydroxide. Sodium hydroxide is a strong base. Sodium hydroxide is a strong base. I said you hydrochloric acid is strong acid. Sodium hydroxide is a strong base. Okay. Now, it is also known as caustic soda. Remember this. Another name. Another names are very important, and molecular formulas are very important, and uses are very important. Okay. It is also known as caustic soda. It is obtained by the electrolytic decomposition of solution of sodium chloride. Electrolytic decomposition. How we get this NaOH? How can we obtain this NaOH? By electrolytic decomposition. Electrolytic, by using passing the electric current, we are going to happen. What is the reaction is happening? Decomposition reaction is happening. Okay. Electrolytic decomposition of solution of sodium chloride. That is called as brine. Remember this word, brine. Okay. In the process of electrolytic decomposition of brine, so what happens? Brine decomposes to form sodium hydroxide. So brine, what happens? This chemical, after doing electrolytic decomposition for sodium chloride, after we pass a amount of electric current, after we pass the electric current and we are going to conduct decomposition reaction, due to this, what is obtained? What we are going to obtain? Sodium hydroxide. In this process, this chemical reaction, if you are going to write, and 2 words if you are writing the same thing, that is enough. Okay. Like example we can see here, sodium chloride plus water will give sodium hydroxide. Sodium chloride and water. By using electrolytic decomposition, what we are going to obtain? Sodium hydroxide plus chlorine plus hydrogen. This process is known as chlor-alkali process. Very important, children. They may ask you this question. Briefly explain chlor-alkali process. What is chlor-alkali process? Briefly explain. Or they may ask you the question like this. How do you obtain sodium hydroxide? Briefly explain. How do you obtain sodium hydroxide? Okay. In this process, what we see, chlorine is obtained at anode and hydrogen gas is obtained at cathode. Remember this. Chlorine is obtained at anode and hydrogen gas is obtained at cathode as byproduct. This process is known as chlor-alkali process. Remember this reaction. Sodium chloride plus water. Sodium chloride plus water in the presence of electrolytic decomposition. Due to electrolytic decomposition, what happens? It converts as sodium hydroxide, chlorine and hydrogen. Chlorine and hydrogen. Where this chlorine is obtained? It is obtained at anode and hydrogen is obtained at cathode. This process is known as chlor-alkali process. Chlor-alkali process. Okay. Next, uses of products after the electrolysis of brine. After doing this, so where we are going to use? Number 1, hydrogen gas is used as fuel, margarine in making of ammonia for fertilizer, etc. Number 2, chlorine gas is used in water treatment. Okay, in water treatment we are going to use chlorine gas to convert hard water into soft water, and manufacturing of PVC, disinfectants, CFC, chlorofluorocarbon, pesticides, etc. It is also used in the manufacturing of bleaching powder and hydrochloric acid. You may have seen the bleaching powder, the water which you are going to get from the pipelines. You can find somewhere the taste is somewhat changed because in the presence of bleaching powder. To clean the water, they are going to add this. Okay, bleaching powder and hydrochloric acid. Okay. Next is sodium hydroxide is used for the degreasing of metals. Degreasing of metals, manufacturing of paper, soap, detergents, artificial fibers, bleach, etc. So these are the different uses of sodium hydroxide. So what is sodium hydroxide? It is a base. Okay. Next, bleaching powder, CaOCl2. Bleaching powder is also known as chloride of lime. It is also known as chloride of lime. It is a solid and yellowish white in color. Remember this state. What is the color? Solid, yellowish white in color. Bleaching powder can be easily identified by the strong smell of chlorine. By using the smell, we can easily identify bleaching powder. How it is obtained? How the manufacture is going to happen? When calcium hydroxide, that is called as slate lime. We have discussed already. Okay, in the reactions which I told you, example, like I told you, about the chemical properties. Yeah, we are going to discuss over there. In chemical property, it is present in your textbook. Okay. Anyways, calcium hydroxide, that is aqueous solution, plus chlorine. when we combine this calcium hydroxide with chlorine, what we get? Bleaching powder. That is calcium oxychloride. Calcium oxychloride. That is called as bleaching powder and water. You can see here also, when calcium hydroxide, that is snake lime, reacts with chlorine, what it gives? Calcium oxychloride. That is called as bleaching powder. Okay. Similarly, aqueous solution of bleaching powder is basic in nature. Aqueous solution. Okay. Aqueous solution of bleaching powder is basic in nature. So it is basic in nature. The term bleach means removal of color. Bleach is nothing but removal of color. So bleaching powder is often used as a bleaching agent. It works because of oxidation. Chlorine in the bleaching powder is responsible for bleaching effect. So chlorine is present in that. Due to that, it gives more kind of shining kind of nature. Okay. Uses of bleaching powder. Bleaching powder is used as disinfectant to clean water, moss remover, weed killers, etc. Bleaching powder is used for bleaching of cotton in textile industry, bleaching of wood pulp in paper industry. Bleaching powder is used as oxidizing agent in many industries such as textile industry, paper industry and etc. Okay. So these are the uses of bleaching powder. Do not forget, if you want you can copy it on these notes also. It comes under your long ancestor notes. You should not forget it. Okay. Next, baking soda. Baking soda, that is sodium hydrogen carbonate. Sodium hydrogen carbonate. Baking soda is another important product which can be obtained using byproducts of chlor-alkali process. From the chlor-alkali process, we got the byproduct which is present at anode and cathode, right? Anode and cathode. By using those things, we are going to make baking soda. The chemical name of baking soda is sodium hydrogen carbonate or sodium bicarbonate. It is also called as sodium bicarbonate. Sodium hydrogen carbonate or sodium bicarbonate. Bread soda, cooking soda, bicarbonate of soda, sodium bicarbonate, bicarbonate of soda, or simply carbonate, we call as just carbonate, etc. are some other names of baking soda. We call baking soda with different names. Now how to prepare? Preparation is important. So baking soda is obtained by the reaction of brine with carbon dioxide and ammonia. This is known as solvay process. Remember, they may ask you the questions like this. They may not ask you the question directly like write the preparation of baking soda. No, they may ask you what is solvay process or briefly explain solvay process. Briefly explain chlor-alkali process. The names could be asked for you in this manner. So you should not forget the other names also. Okay. So what we are doing here, sodium chloride plus water. That is nothing but not brain, it is brine. Okay. It is brine. So sodium source of carbon dioxide. Calcium carbonate. We can see here this calcium carbonate is used as source of carbon dioxide, and the resultant calcium oxide is used to remove ammonia from ammonium chloride. Okay. So this is regarding our baking soda. In this process we can see this calcium carbonate is used as source of carbon dioxide, and resultant calcium oxide, what we get the calcium oxide because of this using carbon dioxide. Okay, what it does, it is used to remove ammonia from ammonium chloride. From ammonium chloride it removes ammonia. It removes ammonia from ammonium chloride. Properties of sodium bicarbonate. Sodium bicarbonate is white crystalline solid, but it appears as a fine powder. Sodium hydrogen carbonate is atmospheric in nature. Sodium hydrogen carbonate is sparingly soluble in water, little bit. It's not completely dissolved, sparingly soluble in water. Thermal decomposition due to heat. Okay. Thermal decomposition of sodium hydrogen carbonate, that is called as baking soda. When baking soda is heated, it decomposes into sodium carbonate, carbon dioxide and water. We can see this reaction. Baking soda, NaCO3, when we heat this product, what we are going to obtain? Sodium. What we obtain? Sodium carbonate, carbon dioxide and water. Sodium carbonate formed after thermal decomposition of sodium hydrogen carbonate decomposes into sodium oxide and carbon dioxide and further heating. The product what we got here, sodium carbonate, then later what we are doing, after we heat again, what we get? Sodium hydrogen, sodium hydroxide, carbon dioxide. This reaction is known as dehydration reaction. So what is dehydration reaction? Sodium carbonate formed after thermal decomposition of sodium hydrogen carbonate decomposed into sodium oxide and carbon dioxide on further heating. This reaction is known as dehydration reaction. Uses of baking soda, we can see here. The baking soda is used in baking of baking powder, which is used in cooking, as you all know it, and it produces carbon dioxide, which makes as butter soft and spongy. Baking soda is also used as an antacid, very important, should not forget this. It is used as an antacid. It is used in toothpaste to make the teeth white and plaque free. Baking soda is used in cleaning of ornaments made of silver. Since sodium hydrogen carbonate gives carbon dioxide and sodium oxide on strong heating, thus it is used as fire extinguisher also. Baking powder. Baking powder produces carbon dioxide on heating. It produces carbon dioxide on heating. If we heat that baking powder, it produces carbon dioxide. So it is used in cooking to make the butter spongy, as we have seen in the application over there. Although baking soda also produces carbon dioxide on heating, but it is not used in cooking because on heating, baking soda produces sodium carbonate along with carbon dioxide. The carbonate produced makes the taste bitter. See students, what does it mean here? So here he is saying that baking powder produces carbon dioxide in heating. If we heat the baking powder, जब हम baking powder को heat करेंगे तो carbon dioxide मिलेगा. Okay, so it is used in cooking to make butter spongy. जब only for butter spongy मिलाने के लिए बस इस्तेमाल किया जाएगा. But we can see here baking soda also produces carbon dioxide on heating, but it is not used in cooking. हम cooking के अंदर इसमें इस्तेमाल नहीं करेंगे because on heating baking soda produces sodium carbonate along with carbon dioxide. जब हम उसको ज़्यादा heat करेंगे the dehydration reaction, ज़्यादा heat करने से क्या होगा, sodium carbonate and carbon dioxide भी मिलता है. It's not dehydration reaction. Okay. So anyways, baking soda produces sodium carbonate along with carbon dioxide. The sodium carbonate thus makes the taste bitter. So NaCO3 plus heat. When we are heating this sodium hydrogen carbonate, that is baking soda, when we heat this product, what we are going to obtain? Sodium carbonate, carbon dioxide and water. Baking powder is mixture of baking soda and mild edible acid. Generally tartaric acid is mixed with baking soda to make baking powder. So we can see the reaction here. Baking soda plus tartaric acid gives carbon dioxide, water and sodium carbonate. When baking powder is heated, sodium hydrogen carbonate decomposes to give carbon dioxide and sodium carbonate. जब baking powder को हम heat करेंगे तो क्या मिलेगा? Sodium hydrogen carbonate decomposes to give carbon dioxide and sodium carbonate. Carbon dioxide gas bread and cake fluffy. Tartaric acid helps to remove bitter taste due to the formation of sodium carbonate. Washing soda, sodium carbonate. What is the preparation method? Sodium carbonate is manufactured by thermal decomposition of sodium hydrogen carbonate obtained by solvay process. We can see the preparation over here. Sodium chloride, carbon dioxide, ammonia plus water. Combination of this, what happens? Ammonium chloride and sodium bicarbonate is obtained. Now again take this sodium bicarbonate. Once if we heat this, what is obtained? Carbon dioxide, water and sodium carbonate, that is anhydrous solution. The sodium carbonate obtained in this process is dry. It is called as soda ash or anhydrous sodium carbonate. So washing soda is obtained by dehydration of anhydrous sodium carbonate. Sodium carbonate plus 10 moles of water, okay, gives us sodium carbonate hydrated. Since there are 10 water molecules, 10 moles of water, that is 10 water molecules in washing soda, hence it is known as sodium bicarbonate dehydrate. Decahydrate. Deca means 10. 10 decahydrate. Sodium carbonate in a crystalline solid and it is soluble in water when most of the carbonates are insoluble in water. Most of the carbonates when they are insoluble in water. Uses of sodium carbonate. It is used in cleaning of cloths, especially in rural areas. It is also used in making of detergent, cake and powder. removing permanent hardness of water, glass and paper industries. Children, this question is very important, should not forget this. Water of crystallization. What do you mean by water of crystallization? Okay, we can see here. Many salts contain water molecules, they are known as hydrated salts. The water molecule present in salt is known as water of crystallization. The water molecule present in the salt, that is known as water of crystallization. Example, copper sulfate pentahydrate. Blue color of copper sulfate is due to the presence of 5 molecules of water. When copper sulfate is heated, it loses water molecules and turns into grey white color, which is an anhydrous copper sulfate. After adding water, anhydrous copper sulfate becomes blue again. So you just remember this, and we can see here. Just you remember what is you mean by water of crystallization. One example, you can just make a note of this, and remember this chemical reaction. So we know acids which turn blue litmus to red, they are called as acids. Bases, those are the substances which turn red litmus to blue. Acids are sour in taste and bases are bitter in taste. Mineral acids, just I am going with a small highlight. Mineral acids, so acids which are obtained from minerals like from the earth crust, that is minerals like sulfates, nitrates, chlorates, etc. are called as mineral acids. Example, your sulfuric acid, nitric acid, hydrochloric acid. Organic acids which is obtained from the plants and animals, and hydronium ions, that is H plus ions. We call them as hydronium ions also. They are formed in the reaction of H plus from acid and water. It is because H plus is unstable in nature. Universal indicator, we have one more type of indicator. It is a mixture of all the indicators which shows a gradual but well marked series of color changes over a wide range of change in concentration of H plus ions. So we don't have that much deep discussion regarding universal indicator. Okay, by changing its color, just we get like a strip, add into the solution, it changes into color and match with the given chart. So it will easily identify. So even you can identify which the composition of that also from them. Strong acids and weak acids. Okay. Chemical properties of acids. If they ask you, write the chemical properties of acids, you can just write this. Like acids react with active metals to give salt and hydrogen gas. They react with metal carbonates, metal hydrogen carbonates to give salt, water and carbon dioxide. Acids react with bases to give salt and water. This reaction is known as neutralization reaction. Acids react with metal oxides to give salt and water. In this, one thing you need to remember, children, when acid reacts with, remember this, very important, metals. When acids react with metals, what it gives? Salt and hydrogen gas. Very important. If acids react with metal carbonates and metal hydrogen carbonates, it gives salt, water and carbon dioxide. Salt, water and carbon dioxide. Write somewhere. It's very important. Acid react with bases. When acid react with base, it gives salt and water. Just salt and water. Here, salt and hydrogen gas. Here, salt, water and carbon dioxide gas. But here only salt and water. So acid react with metal oxides. If it reacts with metal oxides also, it gives salt and water. Okay, it gives salt and water. Only if it react with carbonates. We can see the word here, carbonates. See here. Again, I am going to explain you. When acids react with metal carbonates, carbon present, metal present, acid present. Here also we can see metal is present. Okay, again carbon present. So salt, water is present. And of course carbon dioxide is present because carbon particles are present. Rest all salt and water, salt and water. But only when they react with metal, it gives gas. That is hydrogen gas. Chemical properties of bases. That is reaction with metals. Certain metals such as zinc, aluminum and tin react with alkali solutions. On heating and hydrogen gas is evolved. Bases react with acids to give salt and water. So indicators are substances which indicate the acidic or basic nature in the solution by their color change. By their color change. Easily we can identify. Those are called as indicators. pH scale, it is a scale which is used to measure hydrogen ion concentration in solution. And children, just for you, it's an extra information. But anyhow, we are going to discuss in a higher study. To find the pH, we are going to use the logarithmic table, logarithm. Okay, by using that, just you remember the formula, pH equals minus log of x plus 1. plus hydronium or hydrogen concentration. pH is equal to 7, neutral, less than 7 acidic, greater than 7 basic. Children, this question is very important. Should not forget this. Very important. Seriously, I am saying it's very important. Common name, washing soda. What's the chemical name? Sodium carbonate D decahydrate. Chemical formula Na2CO3 10H2O. Uses: manufacture of borax, caustic soda, softening of hardware. Baking soda, sodium hydrogen carbonate NaCO3, used as antacid, ingredient of baking powder. Bleaching powder is calcium oxychloride CaOCl2. Bleaching cloths used as oxidizing agent, disinfectant, water, manufacturing of chloroform. Plaster of Paris, calcium sulfate, hemihydrate CSO4, half H2O. Plastering fractured bones, making toys, decorative materials, statues. So remember this table, very important. It can give you more amount of marks. So equations, as I said you, when acid react with metal, it gives salt and hydrogen gas. Example, when base react with metal, salt and hydrogen gas. Base react with acid, salt and water. Acid gives hydrogen ions in water. Bases generate OH ions in water. Reactions of important chemical compounds like preparation of bleaching powder. It's very important, as I said you. By the action of chlorine on dries like lime, CaOH twice plus Cl2 gives CaOCl2 plus H2O. On heating, baking soda liberates carbon dioxide gas. And this is the preparation of plaster of Paris. Okay. CaSO4 twice of water molecules and the presence of 373 Kelvin temperature heat, it gives CaSO4 half H2O plus 1.5 moles of water. On mixing plaster of Paris with water, gypsum is obtained. If you mix water, we get gypsum. The same table what I have explained you, I have given once again in the table. Common salt, sodium chloride, chemical formula, what is the preparation? By combination reaction of sodium hydroxide and hydrochloric acid, what we are getting? Sodium hydroxide plus HCl gives NaCl plus H2O. This arrow mark means we can write here. Okay, just we can write here and you can write the product over there. Just if you write this much also, it's sufficient. Okay, how we are going to obtain, and we have got the uses over there. Okay, I hope you all can observe this. Is this visible? Similarly, baking soda, sodium hydrogen carbonate, and you can see the preparation, chemical name, and its uses over there. So we can just, you can see here, by heating gypsum at 373 Kelvin. So under 373 Kelvin temperature, what happens? CSO4 half H2O plus 1.5 times of H2O. Okay, here below table is not visible. Already I have given you the products over there. You can just make a note of those things over here. Okay, just remember these points, very important. Indicators, what do you mean by indicator? What do you mean by olfactory indicator? What is alkali? What is water of crystallization? And you remember this, when acid, the acid must always be added slowly to water with a constant stream. Okay, acid must always be added slowly to water. If water is added to concentrated acid, the heat generated may cause the mixture splash out and cause growth. Based on this point, one question now is already appeared in exam. Okay, so wish you all the best of luck. I hope you all have understood the chapter, the summary of this chapter. Maybe I have gone very fast. Okay, I can't say that I have gone slow, but due to the time consistency, I have done this much. But anyhow, I am going to discuss the question answers still in detail. Okay, just I have done the small revision for you all based on the chapter. So wish you all the best of luck. Don't forget to watch the second episode of this chapter. Don't forget to subscribe, like, comment and share. Thank you. If you have got any doubts, please you can ask me. I'll clarify your doubts.